Hello, everyone. Hope you're having a great conference so far, even though we're pretty early on in the conference, and that you're ready for some talk about C# 6 to 9 and some of the cool features that we've gotten out of Microsoft in those versions. Wrong window. So my name is Klug. I work as a developer / architect / public speaker at a company called Active Solution in Stockholm, Sweden. And I tend to try and go to conferences and talk about things I've learned because I think it's a fun thing to do. And I usually meet a lot of really cool people. And I really hope that we can do this in person next time. That would be a lot more fun. So we're going to talk about C# 6 to 9. But before we get started, there's a little thing I want to cover. So default language versions are quite interesting or quite important for this talk because I am talking about C# features in different versions. So what you need to know are this little chart here, which basically tells you, depending on your target framework, .NET, .NET Core, .NET Standard, or .NET Framework, you can see the versions of that framework and what language version that is the default version. So if you're on .NET 5, you've obviously got all of C# 9 to play with, which is kind of cool. However, if you're on, let's see, I'm just going to do it. If you're on .NET Framework up to 4.8, you're kind of stuck with C# 7.3 as a default. So these are interesting to note, and these are just the default versions. So if you're on an older framework and you don't want to use the default version, you can go into your CS_proj file and you can add this lang version, and then you can tell it a specific version, latest major, latest preview, and it will give you that version instead, which gives you ability to use newer C# features. However, it is important to note that some features in C# that you're getting are not supported by older versions of the runtime. So a lot of features are just syntactic sugar that the compiler will convert into old school IL code for you, and you'll just get cool features, but they're still based on old runtime features. But there are some features that do require you to have a newer runtime, which means that those features won't actually work in your project just because you switch over to a newer version of the language. So make sure you test your applications when you're using new features, but a lot of them are available in old projects as well. Okay, let's just move on from that. We've covered default language versions. You can upgrade them. You can use newer versions. We're going to talk about the 10 best new features in C# version 6 to 9. I also want to mention, if you have any questions, feel free to just send them in the Q&A tab in your window, and I'll answer them along the way. I have a lot of stuff to cover, so it's a 60-minute session that I will try to get into a 45-minute session. So I won't do a lot of answers to questions if they're complicated, and we can take those offline afterwards. But feel free to ask questions along the conversation or along the presentation, and I will see if I can answer you. So let's just get started. At number 10, and remember, there's no relationship between 10 and 1. This is the 10 best favorite and the first one. The numbers are just, they happen to pop up in this order. So don't read too much into the number 10. But at the 10 here, we've got string interpolation. So most of us have probably written this piece of code here, or not that exactly code, but something very similar, where you go and you take the first name and then you add a space, and you take the last name and you add a space, and you add posted in and a space, and then a name, and then so you concatenate this string, which is really tedious. It's actually quite hard to read because there's a lot of plus signs and quotes, and that's complicated stuff to read. And also there are some performance issues around doing string concatenation like this. So as an answer to that, C# introduced this idea of doing string.format, right? So in string.format, you do your string format, you do curly brace 0, 1, 2 positional arguments, and then you add your arguments at the end, which is not easier to read in any way, to be perfectly honest. It's fairly easy to read if you've got what you've got on the screen right now, but if somebody goes ahead and does that, then it becomes really complicated because wait, they're in the wrong order. So now you have to go, okay, so 1 is first name, 2 is last name, 0 is group name, 3 is day of week. So it's just hard. And string.format it's powerful in a lot of ways, but it's also a bit confusing and hard to read, as I said. So in C# 6, they introduced string interpolation that looks like this. So you just add a $sign before your string, and then inside the string you use curly braces. Whenever you do a curly brace notation, you're back into C# land. So in here, I'm just doing user.firstname, user.lastname, group name, and so on. You can read this string much easier than you could the previous one. But you can also do other things. You can have if statements in there, and you can do other things and make more complex choices and add an S at the end if it's a plural and thing and so on. So much easier to read. And in the end, it gets compiled down to string format anyway, but you can read this a lot better. So I love that feature. It's one of my favorite features, definitely. At number 9, we have another one, which is default interface methods, which is one that I'm sort of torn. It's a cool feature. It adds some functionality that's really cool, but it also introduces some interesting questions. And default interface methods is this idea that, say that you have this interface called iEmail-client, and it has one method called sendMail. It's asynchronous, returns task. It has an address from and to and a subject and a body. That's it. Cool, I can send emails. And then somebody at that meeting goes and at some meeting with your company goes and says, shouldn't we use templates? Templates are much better. We should use templates. And then you're sitting in that meeting going, oh, okay, so it's not a big deal, but okay, so let's do template-based emails. So you add this interface to the iEmail client where you say send templated email, where it takes like an address from and to, a template, and then a dictionary of replacements so that you can replace values in there. And then you add that and you look in Visual Studio and it says, oops, email client does not implement interface member, blah, blah, blah. And that's because there's already an implementation of iEmail client. So now you have to go and update the email client implementation so that it has that extra method from the iEmail client as well. And if you're unlucky enough to have actually published this interface as a NuGet package, it means a breaking change. So it means that you have to do a major version because you're breaking anything that's out there. So it's another major version release and so on. It's a bit of a pain, to be perfectly honest. So in C#8, they introduced this idea of default implementations or default method implementations. So what we're allowed to do now is on an interface, when you declare an interface method, you can also add a default implementation and that's really cool. The only caveat here is that the default implementation can only use things it knows about. So it can only use arguments that are coming in, and it can use methods on its own interface. So in this case, it can piggyback on the send email method that was there before, but it can also add support for templating in this way by basically saying template.getSubject and template.getBody and pass those values in to the other implementation. So this means that anybody that's implemented iEmail client will get that functionality by default, and then they can override it and do their own if they want to, but you're not introducing a breaking change. We can publish this new interface and it will work for all old implementations, and you don't need to have a major version update. Default method implementations, really cool idea, gives the ability to sort of do some things that you would probably have done as extension methods before, but have them as part of the interface instead now, which is cool. At number 8, we're looking at out variables. This is a tiny little feature, but it's oh so important in my world. We've probably all written this piece of code here or something very similar. You have this try parse method, very common in C#. You go int try parse, it needs an out value. So basically you have to go out value, and then you have to declare that thing up there, which is, why do I need to declare that? That's really annoying. I really don't like it. Especially if you do, instead of doing an if not try parse, you just do an if try parse, and then you just want to use the value inside of there. There's an extra variable. It annoys me. I'm sorry. It's that simple. It's just an annoying little feature. It might not bother everyone, but it does bother me. So in C#7, they went ahead and made some changes to C# and said, hey, how about we just do it like this? So instead of having to declare the int value variable before the try parse, we can declare it as part of the out statement. and then it's available from that line and beyond, which means that it's available inside the if and it's available after the if. And in C#8, they also said, hey, how about allowing us to do that instead? So we do out var value. We don't have to type it to int, which is quite nice. I do like the var keyword in C# because it's just easier to write than having to write out the type all the time. So for int and var, not a big deal, but if it's an out parameter that has a long variable name or a long type name, it's kind of annoying. Okay, we're rushing ahead here, going fast, but these are small features so far, but they're quite useful. And we've got to number 7, which is expression-bodied members. Once again, tiny little thing, kind of cool, and it's based on this idea here. If you're creating this class called product, and the product has a name and a price, and you want to have read-only properties for it, you would have to write something like this in the early days. You would have a backing field called name and a backing field called price, and then you'd have public string name and a get. And there's a lot of code in here. There's a lot of curly braces. There's the actual property. There's the getter. It's just quite a bit of code. So they also decided to introduce this a while ago. Not actually know the version of C# where you can do private get set, so you can do public get and a private set. You remove the backing field, but there's still quite a lot. If you've got many properties, that becomes pretty large and unwieldy. So in C#6, this is an old feature, but that doesn't make it bad in any way. So in C#6, they decided to give us this instead. So now we have public string, and then you use that arrow, fat arrow, whatever you want to call the equals greater than symbol, name and price in this case, and then you have your backing field. So you're back to having a backing field, but you're allowed to just return it using the arrow syntax instead, which is quite nice. And it becomes a one-liner. It doesn't take up as much space. However, if you want to do get set, you're back to this. So if it's a get and set, you have to include both of them, in which case it's probably easier to just go get semicolon, set semicolon, and remove the backing field, to be perfectly honest. But in C#7, they decided that, hey, we like that idea of having gets and sets because you could do things in there. And they decided to add expression-bodied members to the gets and sets as well. So now you can go and do public string name. You can have get fat arrow or arrow name, and then set arrow name equals value. It's just a fewer less curly braces. I'm not sure. I think this is a major thing, but the read-only ones are quite nice. This I could just do without, to be perfectly honest. And then they also introduced this idea of, we have all these, not all of them, but we often have small methods like toString, for example. toString is often a very simple method. It just needs to return a string, and we use string interpolation here to basically build up the string. But we still need the curly braces and the return statement and all of that. So in C#6, once again, as before, they did introduce this idea of allowing us to do expression-bodied members for methods as well, which makes this much smaller and simpler, and we get rid of the curly braces that are just there because they have to be there. And in C#7, they took it one step further, and they said, hey, let's allow the developers to do expression-bodied members for constructors and destructors as well, or finalizers. So once again, kind of cool. Not sure I've ever used them, to be perfectly honest, because a destructor is often more than just a log statement. If you use them, there are often a bit of code in there to figure out what to do. And my constructors are often more code than just one parameter in and one parameter that needs, or one field that needs to be set, which means that we can't use this. But for really small things, you get rid of some curly braces. Kind of a neat feature. Okay, number 6, discards. Discards are weird, but they're actually kind of awesome as well. So imagine you have this class here that has 2 methods. It has do something and do something else. And as you can see here, do something else it returns a task of string. And in the do something method, we await that do something. But it's kind of weird because if you look at this code here, you might start wondering here, did someone forget that this thing returns a string, or Was it intentional? Do we not care about the string? What's actually happening here? And might not be a big deal, but it does make me wonder when I see code like this and you go, wait. There is a return value, but why are we not listening to the return value? So in C#7, they introduced this idea of discards. So a discard is just this underscore. And in this case, you can see here, I do discard equals await. And the cool thing here is that discard is very obvious to any developer coming after me that, okay, Chris didn't want to have this thing here. He knows that there's a return value, but he doesn't care. He's made a conscious choice to ignore what is coming back, which is maybe not a big deal, but it removes that question of did he forget something or what's happening here. This is very explicit. But even cooler is that if you go and do this, for example, say that you want to do a fire and forget. I don't even want to await your task. I just want to go and run it and go and do your thing, and I will carry on doing my thing. That can run on the background thread. It's not very important. It might be like a useless log statement that is not important, so you don't care if it crashes or whatever. So you do this, you just call it, and you just ignore the fact that it returns a task. And in Visual Studio, you get this warning because the compiler gives you a warning that says, you did not await this thing. You probably want to await it. And if you have OCD like me and you want to get rid of all your warnings, that is annoying. And this is where you can once again go in and just say discard. I know what I'm doing. It doesn't just tell developers coming to the code after you. It also tells the compiler, I know what I'm doing. I don't care about the return value. So that's kind of cool. We can also use it for another thing, which is quite nice. We've probably all also written this kind of code, so verifying input parameters. You verify that the name is null, and I keep forgetting to change this slide. It should be name length less than or equal 0 to verify that it's longer than nothing. And then we do throw statements. And this becomes quite long. If you have many parameters that need many checks, it becomes a pretty long part at the top of your class to verify all the arguments. With discards, we can do this now. So we can say discard, I don't care about what you're returning, and then we use the double question mark to say if it set the discard to name, or if name is null, throw an argument null exception. And we can say set the discard the return from if the length is larger than 0, should once again be rewritten, sorry about that, return name or throw argument exception. So this allows us to do those two checks that we had here in one-liners, and we do it with the discard, which is nice. We can't do it without the discard, so the discard here is important because you're not allowed to write these statements without saving the value somewhere, but we're saving it to discard, so it just goes away. And it also uses a C#7 feature called throw expressions that allows us to throw exceptions as part of an expression, which wasn't allowed before, but now we are, so it allows this really cool syntax, which I'm using in pretty much every project I'm working on right now. We have this type of validation. Okay, at number 5, we have null conditional operator and null coalescing assignment. And these are two features. I put them together and made them into one, even though they're two separate features, but they still work with null. And so I'm actually giving you 11 features, but don't listen to that. I'm giving you these as one. So it's going to be 10, but I'll just leave it at that. But we're going to start off with null conditional operator. So the null conditional operator helps us with code like this. Say that you have code like this, where you want to get to the email address of the recipient of an order, but you don't know if the order is null, so you have to check that first, and then you have to check if the recipient is null, and then you have to check if the email address is null, and then you can send the email. Really annoying piece of code to write. Can also be simplified a little bit by this, so you can do it in one big if statement, which is better, but it's still quite a bit of code. So in C#6, they added this null conditional operator, which is really cool because it allows us to do this. So this thing here with question mark dots, also called the Elvis operator, it says that if order is null, then the whole thing becomes null. If order is not null, it looks at recipient. If that is null, the whole thing becomes null. Otherwise, it looks at the email address and returns whether or not that is null. So this whole thing basically says, if there is an order with a recipient and the recipient has an email, then go and send this email, which is much, much nicer and shorter. So that's pretty cool. And the null coalescing assignment operator is very, very similar. It looks like this. So imagine you have this method here that basically just says, if you passed in null, I'm going to give you a default of options. Not a big deal, but it's 3 lines of code just to set a default. In C, and probably it should be an overload, but ignore that. Imagine you have this code. C#8 allows us to do this. So it basically says options should be what you have passed in, unless you passed in null, in which case I want you to assign my options.default to options instead. So yes, we have come to the point where we need 3 character operators in C# apparently. And my friend Martin Baljau suggested that we should call this the Ace Ventura operator. I'm going to fully support that. So this is now called the Ace Ventura operator. But it's kind of cool. Number 4, nullable reference types. This is a big deal. So nullable reference types is a huge feature, and it basically removes this piece of code here. So here we have to check if value is null because it's a reference type, and any reference type in C# can be null. So we have to verify that it's not null before we use it. In C#8, we can go and say, nope, reference types should never be allowed to be null unless I specifically tell them to be null. So that means that we can remove the null check, because if I have turned on, if I have nullable reference types, string value can never be null because it's not allowed. So any reference type has to be assigned to something, can never be null unless you explicitly say that it's null. So you write this code here, you run it on .NET Core 5, or sorry, .NET Framework 5, so you've got C#9, and then you write this piece of code here where you explicitly turn your value to a string, nullable string, which is whenever you want to have a reference type that can be null, you have to add the little question mark. And then you pass that in, and you run the code, and it runs, and you get null reference exceptions, and you go, oh no. That bold Swedish dude told me that with C#9, this should work. I should not be able to pass in null here. And you go, but you said we cannot have null values. And yes, I did. But you have to turn it on. So this is a breaking change, right? Because all old code is going to fail on this because it assumes there could be null values. So it is a breaking change to C#, which means that you have to manually turn it on in your project file. So if you're on .NET Core or above, you can do nullable enable in your CS proj file. And if you're on .NET Framework, it's supported there as well, but you have to go and update the language version to 8, and then you can add nullable enable as well, and you're good to go. So that then happens that we don't have to change this code here, because this works, because it just assumes string has a value. However, if we don't make a change here, we just leave that, and we try to compile our code, we're now going to get a possible null reference argument for parameter value. So it figures out that, you probably need to fix this. So it tells you that you're doing something wrong, that you might be passing in a null value where you shouldn't be, which is really cool. If you really do need to have a nullable type, then you just add a question mark, and now all of a sudden string question mark means that you've got the old version of nullable reference type, so you can null them out. And then you can basically take that and you can combine it with the null coalescing stuff and the null conditional stuff and so on to make it a little bit easier. You can also go and say, if you've checked the value and the compiler still can't figure it out, and it still says this might be null, then you can go and say with an exclamation mark, I know what I'm doing. This value here has been checked by me. I know what I'm doing. It is not null. And then you get rid of that warning because you have checked it yourself. However, make sure you check it, because otherwise you're back to trying to do null.length, which is not going to work. However, interesting point here is this thing here. You get a warning, possible null reference, blah, 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 that I showed you before. Yes, nullability is just warnings. So when you enable nullability or nullable reference types, then anywhere you break that and use a null value instead of an actual value or possible null value, you get a warning which will not fail your build. It will just be a warning. if you're starting a new project and you want to make sure that you're on track with this and everything is properly handled with null, you have to go into your project file and add warnings as errors and nullable. That will take any error that code that you're getting from nullability stuff and turn it into an error, and all of a sudden your code will now compile with nullability issues as errors, and it will fail your builds, which is really cool. So now if you're starting a new project, turn this on and you get rid of all of those potential null reference exceptions that you might be getting in a project. You can also use these pragmat hashes here and say nullable, enable, and disable. So if you're on an older project that you worked on for a while and you want to turn on nullability checks, you can either turn them on in the CS proj file and then disable them in the code for the code that you haven't had time to go through yet, or you can have it disabled in your CS proj file and then enable nullability checks in those parts of the code that you have checked. So nullable, enable, disable, and nullable restore allows you to turn on or off nullability checks for a piece of code and then return to the default that is in your CS proj file. So that's nice. A nice way to get started with nullability checks. Just don't get discouraged when you turn it on an old project and you get 20,000 errors that you need to, or warnings that you need to sort out. That's just C# for you. So we're getting closer to the end here, but we've got number 3, named tuples. So lots of us, probably all of us, have probably written code like this at some point. We create this stupid return value class that needs to return 2 values. And since C# cannot return 2 values, we need to have a specific class for it, or use out parameters, but you can't use out parameters in an async operation. So we end up writing these stupid classes, in this case, one that has a is success and then a string that is the actual response. So in C#4, the introduced was called C# tuples. And that allows us to return a combination of values. So it allows us to return a tuple like this. So we can return true, and it worked. And you can see here we define it as parentheses, bool, and string. And I really, really, really tried to love this. I wanted to love this. I wanted to work with it. I wanted it to be the stuff of dreams. But when you get it back from the do something method, you get a response back here. And then you have to go and look at item 1 and item 2. For bool and string, that's fine. But what if you need to return more than one string, or more than one bool, or more than one integer? If you have several ones, they just come out as item 1, item 2, and you have no idea which one is which is really, really not good. So every time I start using the C# tuples, I end up rolling back and creating my own classes. I don't think I've ever put a tuple in production, unfortunately, because this is hard to read. So in C#7, they introduced value tuples, which is different. They are available to all of .NET Framework and .NET Core and .NET. But if you're on less than 4.7 for .NET Framework, you need to add a NuGet package called system.valueTuple. And it allows us to do this instead. So now we return a tuple, but we give the parameters names. So bool is success, string is response. You still create the response with just ordinal values. So the first thing becomes the first thing that's returned and so on. But those properties then get turned into this. So we can go and say response.isSuccess, response.response to get the information back that we want. And we got named variables, named properties. One thing to note that C# tuples are still there together with value tuples. They are very, very different. So C# tuples are immutable reference types. So basically they become classes that are reference types, and they have properties, and they are immutable. So they're get-only properties. Value tuples are mutable value types with fields. So they don't have properties, they have fields, public fields. And because of that, they are mutable, but they're really nice because they're value types, so they're quick and so on. But it's important to note that a C# tuple you cannot change, a value tuple can be changed. We also support something called deconstruction. So if you're returning a value tuple from do something, we can split that into 2 separate variables if we want to instead. And then we've got that whole thing again, but we've already covered that was not great in the out stuff. So now instead we're allowed to do this. So we can just do bool is success and string response. So when the value tuple from do something comes back, it gets split into isSuccess and response variables instead of having an object. And we can also, to make it even simpler, we can just put the var in front of it so that it figures out the types on its own, which is nice. And if you don't care about one of the values, you can just do a discard, right? So if you don't care about the response, you just want to know if it worked, then hey, I don't care. Discard, and we're good to go. So in 7.3, they actually added another cool feature, and that's equality comparison. So here you can see that I create two tuples, they have the same values, and that means that the equals and not equals works fine. It outputs the expected value. Little caveat here is that this also seems to work, and you go, wait, what? It does not care about the property values at all, or property names. It just looks at positions. So it looks at int at position 1 equals int at position 2, string at position 2 equals string at position 2, then they're good to go. Whether or not it's called x and count or y and product, doesn't care. Very important note. Okay, let's carry on with one more really cool feature, which is pattern matching and switch expressions. So this is a big feature, which is why I have quite a bit of time left, hopefully, to cover this. So imagine this code here. I've written this static log method. It takes an object in because I want to be able to log anything. And it starts out with checking if it's null, then it doesn't actually do anything. And then it checks out if it's a string. If it is a string, then it casts it to a string, verifies that it's not string.empty, and then it console writes line the item. Otherwise, it checks to see if it's iLoggable, which is an interface for logging. And then if it is an iLoggable, I cast it to that. Then I check the log level, and then I log stuff based on the log level. And then finally, I just write out the item with unknown in front of it. So that's kind of okay, but it's a big piece of code. And in C#7, they said, hey, let's make it a little bit better. Let's go ahead and allow us to do an is string and then have the variable afterwards and actually do the cast for the developer automatically. So in this case, instead of doing if item is string, and then on the next line do str equals cast string is item to string, it will do the casting for us as part of the if statement, which is nice. It removes one line of code. Yay. But they also allowed us to do this. So I'm going away from the if else into a switch statement. And this is using pattern matching. So now I'm switching on the item up here, and I case null or empty string, then return. So even if I'm passing in object, I can compare it to empty string, which is nice. Otherwise, if it is a string, cast the value for me and console write that value. If it is iLoggable, please cast it to iLoggable, the variable loggable, and then do a when statement to say, if it's iLoggable and the log level equals error, then do this. Or if the log level equals warn, do this. Otherwise, please just go ahead and give me the iLoggable instance, and so I can log the loggable.message in here without the when statement. And then finally, there's a default at the end. So this is easier to read, right? It becomes quite nice to read because it's a case, and you can do both type checks and value property checks and so on in one place, which is nice. It also allows us to do x is null, which I really, really love. It's a tiny little feature, but I love it. In C#8, we got this switch expression, which is another way of shortening our code, where we go and say, get error message, pass in object, and then it does the same thing, kind of, but in a much shorter way. So everything here has to return something. So every check here has to return a value that is returned from this method. But as you can see, it basically, I switch on the item, and then if it's null, return empty string. If it's empty string, return empty string. If it's iLoggable, sorry, I was one step. If it's string, return string. If it's iLoggable and the level is X, then do that. And then if it's loggable, return the message. If it's unknown. So we get these really short, nice things where we can shorten down big methods like the one we had before into a simple switch method or switch expression that's basically the whole method. And then we've got this thing here. So in this case, we know that the error message is loggable items. We know it's an iLoggable already, but we can still use switch. But in this case, instead of doing when, because we're not checking the type first and then if the type's property is, because we know the type. So instead, we have this curly brace syntax that says, oh, if the log level property on the item is log level.error, then do this. So once again, pattern matching in C#, which is nice. And also, don't underestimate the fact that you can use two variables in here, or two parameters. So in this case, I'm getting both an item and an area, and then I switch on the item, but I use both the item and the area inside of my code, for example. Or you can get two parameters in, you create a tuple out of it, and then you switch on the tuple, allowing you to match both values. So basically, here is two values, put them into tuple, switch on them, and you can do this rock, paper, scissors thing really, really simple. And then finally, if you don't care about the values, you can fall back and use discard to say, I don't care about the values that are in those places. So pattern matching is really, really powerful. And in C# 9, they went even further. So this is something that's getting expanded. So imagine this method here. There's a lot of stuff in here, but basically, I look at the file name here, and I want to verify that it's a valid file name. So I do a callback here with the fat arrow function. So x, and so for every letter in file name, I check to see if the letter is, and then parentheses, and it says if the value is larger than or equal to small a, and lower and or equal to lowercase z, or same thing but with uppercase, or dash, or dot. Very, very easy to read in one line, very compact, even if it's actually quite complicated. And then the same thing here for get extension, I check to see if the length is, and then between two values. So instead of saying if length is greater than or equal to 2, and then another extension dot length equals blah, blah, is all in one place, which is nice. And also in C# 9, we got x is not null. And dude, that is so much better than exclamation mark equals, right? That is very, very readable. I love it. Okay, so the final one we've got is another big feature in C#. It is record types. So a lot of people are talking about record types as it's the new big thing in C#. And it kind of is, but it's for very specific scenarios, I would say. Or not very, but somewhat specific scenarios. But wait, so record types, we've got value types and we've got reference types in C#, right? Are we getting a new type of object? And that's a very common question because we've got value types and reference types, and now people are talking about record types. No, we are not getting anything else. We're not getting a new type at all. Records are immutable reference types with default implementations that's generated for us. So they're just reference types. They're just like a class. But imagine that you have this class here. Simple order. It's got 3 properties: ID, article, name, total. We have to have a constructor. And inside the constructor, we need some boilerplate code here and here and here and here, which is it's just there because we needed a very simple immutable class to represent an order. And we needed all of that boilerplate code. And then somebody comes and says, oh, we also need equality checking. So if we want to have equality checking, we need to go and implement equals and get hash code and the operator overloads and the toString method. And it just goes, whoa, over the top all just really, really quickly. So even if we just wanted a small, simple class, immutable class, it became complicated. So in C# 9, they distilled all of that code into this one line. So you say public record order, and then you give it the properties that you want as sort of constructor parameters. So you do int ID, string, article name, decimal, total. And yes, the casing here is proper Pascal casing. And the reason for that is that the names of the arguments here become the properties on your class. So it just creates a reference type for you. And then you get this here. So you just go and say new order, 1, test, 12M, 2, test, and then you get equality comparison. So it creates a reference type for you with those values, and the equality comparison is proper. It's not reference comparison. It's actually it is value comparison between them, and you get a toString overridden as well. And you just look at that and you go, all of that code went into that one line. It's just such a big deal. And we also got this cool thing here. So if you look at this with here, so first I create an order, I give it a 1 test 12m, and then you say with, and that basically says, take order 1. I want to have a copy of order 1, but I want you to replace the article name with test 2. Or in the second case, I want you to take a copy of order 1 with no changes. So order 3 becomes a proper replica of order 1, but as you can see, the reference equals here is still false because it's not the same instance, because the with operator creates a clone. You can also implement inheritance, so you can inherit a discounted order or a record, sorry. And when you inherit a record like this, you just do it the same as you did before. You inherit from order, and then you can add your own constructors, you can add your own methods, you can add your own properties and things like that. So you can extend it like you would any other class. So that's kind of cool. And that is actually kind of it. I did finish quite on time, but I do want to mention before we carry on, or you carry on for the rest of the conference, or if you have any questions, I just want to mention one thing, and that is these are my favorites for C# 6 to 9. And I want to mention that because different developers in the .NET world work on different things, which means that we have different favorites in the language. I like these because they work well with the type of code that I develop. But if you're a low-level developer building really high performance stuff. If you look at, for example, Kestrel from ASP.NET Core, they have other features. They use span of T and things like that, which are other C# features that work very well with their type of code. So if you're on different type of code than me, these might not be your favorites, but I think these are the best things in my world. Other than that, I just want to thank you all for listening. I am around for a couple of more minutes if you want to ask any questions. I don't see anything in the Q&A in my my backstage here. And I'm not seeing anything. So if you don't have any questions, once again, I want to thank you. If you have any questions you want to take offline, you don't want to do them online here right now, just ping me on Twitter. You got my nick there @0col, and I'm available for questions whenever you feel like it. And if you want to have weird rants about things on Twitter, feel free to follow me for that as well. I rant about this, that, and everything. Other than that, thank you so much for everything. I'm hoping you got a good conference and that this session gave you something that you could use. And once again, looking here, it said something about starting Q&A. Feel free to start a Q&A if you haven't already. Okay, so I can see in the chat here that there is somebody says that I don't look as crazy and as live as I do in the pictures. No, I look slightly less scary in real world. I did not tattoo that on my face. That is true. Let's see. So how can I start the Q&A somehow? Can't see anything about that. Well, you got the chat if you want to ask any questions. Other than that, my stream is apparently stopping in 876. Thank you, guys. I'm available on Twitter. Have a good day.